Hey guys, this is Professor Janacek. I want to go over an example where we graph a curve in space. So we're going to look at a curve defined by r of t. Notice this is our parameter here is t, and it's defined by this vector. So this is a vector valued function defined by the vector 0, 4 cosine t, and 16 sine t. Yes, we are in 3 space here, r3. And our parameter t goes from 0 to 2 pi. Well, to begin with, I did go ahead and create this graph here at the bottom so you can see what 3 space will look like. Notice x is the axis that's coming out towards us, out of the page, and y and z. Y is our horizontal axis, z is our vertical axis. There are other ways of labeling these, but just make note of how I've done this. All right, I think that it is quite useful to go ahead and make a table of values like you might have done in an algebra or even a pre-algebra class when first learning to graph. So our first value is our t value, that's what we choose, and then x, y, and z are all dependent on that. So t is our independent variable, if you will. So let's see, t goes from 0 to 2 pi, so let's just go with some simple computations. Let's use 0. If t is 0, well, obviously our x value, the first component, is 0 and will always be 0. For cosine of 0, well, cosine of 0 is 1. Multiply that by 4, we get 4. And the z value, 16 sine of 0. Sine of 0 is 0. 16 times that is still 0. So there's our first ordered triplet, 0, 4, 0. And yes, you could think of this as a point, but it is, you do want to consider the vector that goes from the origin to that point. All right, let's see, what else? The next t value, and we'll plot all of these here in just a minute. We'll do them. You can plot them as we go along, but I'll just put them all together at one time on the graph. Let's see. Another easy angle to work with computation-wise is pi over 2. Yes, you could do pi over 4, pi over 3, pi over 6, all those really great angles, but I'll just go with these very, very basic ones. Let's see. If t is pi over 2, x again is still 0. And it turns out our y value is also 0. Whoop, whoop. Where'd that go? There it is. Our y value is also 0, but our z value now is positive 16 because the sine of pi over 2 is 1. Okay, moving right along, let's try a t value of pi. Again, really nice to work with, dealing with sines and cosines. The x value again is 0, as it has been. Cosine of pi is negative 1, so we get negative 4, and sine of pi is 0, so we're back to 0 on that one. And let's take a look at 3 pi over 2. For 3 pi over 2, again, the x value is 0. The y value is, let's see, cosine of 3 pi over 2, we get 0 again. And sine of 3 pi over 2, this time is negative 1, so we get negative 16 on this one. And we'll finish up, go all the way out to 2 pi here, which ends up being the same as 0. All right, so there are the ordered triplets, which we can plot here. I'm going to go ahead and go by single values along the y-axis. Notice all the x values are 0, so I don't need to worry about going anywhere on that. Since the y-axis has to be the same calibration all the way across, I'm just going to label the positive side. Now the z's, just to make it a little easier, I think I'm going to go by 2's. Notice I'm only labeling every other one just because it's kind of small. You could, of course, enlarge the graph and label all of them. But again, I don't need to label the negative side because the negative side is going to be the same as the positive. You can't change calibration from the positive to the negative side of an axis. Oh, did I go far enough? Oh, I probably didn't. Let's go ahead and extend this. Oh, I know what I did. I wrote these incorrectly. There we go. Now, okay. And I should probably go one further out there. Okay. Now, if we plot these 0, 4, 0, that's 0 on the x-axis, 4 on the y-axis, and 0 on the z-axis, which is really just like a it is a y-intercept. 0, 0, 16, oh, that's a z-intercept. 0, negative 4, 0 is out here, and 0, 0, negative 16 down here. And then, of course, 0, 4, 0, we've got that point already. So what does this look like? You know what? Actually, let me back up just a bit. Let me do a better job on spacing these out. I think that's going to be a little bit better. Make sure these are properly labeled. Oh. There we go. Now, looks like we have, if I can get this pin to work properly. Do I have that in the right spot? All right, looks like we have something that's really just in the YZ plane. And, oh, that's not very good. It's a little longer vertically than it is horizontally. Oh, gee, this is really, my lack of artistic ability is showing. Well, it looks like what we have is an ellipse that exists only in the YZ plane. So it's always a good idea to kind of identify what it is you're looking at. So we have an ellipse in only the YZ plane. Well, enjoy!